Welcome to Learning with Philemon. In this video, we will be looking at the steps in radical substitution reactions. In the previous video, alkanes, we saw that alkanes can be converted to halogenoalkanes by reacting them with a halogen in the presence of UV light. This reaction follows a radical substitution mechanism. In the previous video, we wrote a single balanced equation for the reaction. This is the overall reaction. However, the reaction consists of multiple steps. The first step in the mechanism is called initiation. The energy from UV light is enough to break the bond between two halogen atoms, in this case chlorine atoms. Two radicals are formed. Radicals are species that have at least one unpaired electron. The unpaired electron is denoted by the dot in front of the chlorine. Note that a chlorine atom contains 7 valence electrons. Its electron configuration in its highest energy level is 3s2, 3p5. Therefore, 6 electrons are paired, and 1 electron is unpaired in the 3p orbital. For a recap on this, rewatch the electron configurations video. The breaking of the bond in such a manner is called homolytic fission. In homolytic fission, a covalent bond breaks, and each species retains 1 electron from the bond. The two species created in this case are the same. For more details on the mechanism, watch the second, higher level half of this video. The second step is called propagation. In this step, new radicals are formed. Radicals are very reactive species. They react in order to obtain a full valence shell. The chlorine radical formed in the previous step reacts with ethane, C2H6. In this step, a carbon-hydrogen bond in ethane breaks homolytically. As a result, the C2H5 radical forms. The chlorine radical bonds with a hydrogen atom, forming hydrogen chloride, HCl. Multiple propagation steps are possible. The C2H5 radical may react with chlorine gas to form chloroethane, C2H5Cl, which is our intended halogenoalkane product, and another chlorine radical. This chlorine radical can go on to react with another ethane molecule. Thus, there is a propagation of the reaction. The final step is called termination. In this step, radicals combine. There are multiple reactions possible. A C2H5 radical may react with a chlorine radical to form chloroethane. However, two C2H5 radicals may also react to form butane, C4H10. This highlights one of the issues with a radical substitution mechanism. There are various byproducts that are formed, such as longer alkanes. In this case, we have shown that butane can be formed. Chloroethane may also react with another chlorine radical, starting the process again. As a result, more than one hydrogen atom, or even all the hydrogen atoms, may be replaced by halogen atoms. Now let's take a look at the mechanism in more detail. Note that this is only required for higher level students, but may help standard level students understand the reaction better. As discussed previously, in the initiation step, UV light is used to break the bond between the two chlorine atoms. A single-headed arrow shows the movement of 1 electron to each chlorine atom. In organic chemistry, arrows show the movement of electrons towards nuclei. A double-headed arrow represents the movement of an electron pair. This will be seen in later videos. As a result of this homolytic fission, 2 chlorine radicals are formed. In the propagation step, a chlorine radical reacts with ethane. 1 electron of the CH bond is retained by the carbon atom, and 1 electron is retained by hydrogen. Hydrogen uses this electron to form a bond with a chlorine radical. The unpaired electron of the chlorine radical is involved in the bonding. In the termination step, the two radicals combined. The unpaired electrons are used to form a bond. Thus, a carbon-chlorine bond is formed. It is easy to make mistakes when writing these reaction steps. To consolidate your learning, I would recommend that you either write the equations or draw the mechanism for each step for another reaction between an alkane and a halogen. Thank you for listening. If you haven't already, please subscribe for more content. Stay curious.